So for today's video, we will be talking about the mode of a dataset, and in simple terms, the mode is actually the variable in the dataset that occurred the most, or we can say the mode is actually the variable in the dataset that has the highest frequency or that has the highest occurrence. So let's kickstart the concept of the mode by using this dataset of ours. So our question says that Michael is interested in knowing how much his friends spends on average in a day. He decides to ask each of them how much they spend and gets the following dataset. So we have $12, we have $15, we have $17, down to $15. So the question says we should find the mode of this dataset. Before I solve this question, it is possible for our datasets to have two modes. It is possible for our dataset to have more than two modes. So if we have just one mode in our dataset, it simply implies that our dataset is unimodal. If we have two modes in our dataset, it simply implies that our dataset is bimodal. And if we have more than two modes, that is 3 modes, 4 modes, 5 modes upwards, then we can say that our dataset is multimodal. So that being said, let's solve the question. So we can see that 10 actually occurred just one time in this dataset, 11 occurred just one time, 12 also occurred just one time, 13 occurred one time, just once, 14 also occurred just once, 15 occurred 2 times, and 17 occurred just once. So we can see that 15 occurred the most. It has the highest occurrence by occurring more than once, that is, it occurred twice. So that simply implies that the mode of our data set is actually equals to $15. So let's move to the next question. So this question of ours says that in a class, a midterm test was conducted and the result of the test is given below. So we have 11, 17, 12, 15 down to 20. So the question says we should construct a frequency table for this data set and find the modal value. So that simply implies that we have our data set in the ungrouped manner or in its raw form, and then we want to actually group this data set by constructing a frequency table. So we've actually constructed a frequency table for this dataset when we were trying to get the median of this dataset. So I'm going to link a video in the top right corner so you can just quickly check how we constructed the frequency table. I'm going to rush through the frequency table right here. So we have we have the horizontal line, and then we have the vertical line. So we have our x to represent the variable of interest, so this is x right here, and we have the frequency, which represents the number of times the variable of interest repeats itself. So we have 10 to 20, so we have 10, we have 11, we have 12, and down to 20. So like I said earlier on, I said that the mode of our dataset is that variable in the dataset that has the highest frequency. So the highest frequency in this dataset of ours is actually 5. We can see the 5 right here. So that means that the variable pointing to 5 is actually 15. So we can say that the modal value or the mode of our dataset is actually equals to 15. So let's work on the third question. So the third question says that the management of a gym is interested in knowing the age distribution of people that visit the gym. So for this, the management decides to look into the ages of people who registered for the next 6 months. So below is the frequency distribution of the age and find the modal value of those distribution. So the first step is for us to get the formula that we are going to be using to get the mode of our data set. And as you can see, this is actually a grouped data, and it is actually grouped based on class. So we have our 6 classes right here, 15 to 20, 21 to 26, down to 45 to 50. So the formula for getting the mode of this kind of distribution is going to be we have our mode is actually equals to LCB subscript M plus we have a big bracket right here that says FM minus F1 divided by FM minus F1. Then we have a plus FM minus F2. Then we have a times C. So the LCBM subscript M simply implies that we're talking about the lower class boundary at the modal value. The FM represents the frequency of the modal value. F1 represents the frequency before the modal value, and F2 represents the frequency after the modal value, and C represents the class interval. So it simply implies that if you are trying to extract out the details from our frequency table, all we actually need is just the class boundary. So let's try to sketch that. We've also sketched this frequency table before where we cut the class boundaries, so I'm also going to still link the video to that in the top right corner so you can just check that out. So we have the horizontal line right here. So we have this vertical line right here. Excuse me, let me redraw that again. So we have this vertical line right here, and then we have another vertical line right here. So we have the variable of interest, which is x. In this case of ours, that is h. So we have the frequency, and this place is going to be occupied by the class boundaries. So we have this to be 15 to 20. We have this to be 21 to 26. So let's quickly rush through that. So for us to get the class boundaries, we are going to be subtracting 0.5 from the lower class limits and add the 0.5 to the upper class limits. So 15 minus 0.5, that gives us 14.5. 20 plus 0.5, that gives us 20.5. 21 minus 0.5, that gives us 20.5. And 26 plus 0.5, that gives us 26.5. And we do the same for all of the other classes. So now that we have our class boundaries ready, it's time for us to get the details needed to get the modal value. So the first step is for us to get the mode, or to know the region where the mode lies actually. So taking a look at our frequency, we can see that the highest frequency is actually equals to 18. So that simply implies that our mode or our modal value is going to be somewhere around this region. So we can say that our modal value is definitely going to be somewhere here. So let's get the necessary details. So the lower class boundary at the median, the lower class boundary at the mode rather, so that is a LCBM, is actually equals to 32.5. At the frequency at the modal class, we have that to be equals to 18. At the frequency before that of the modal class is going to be equals to 7. So that means our F1 is actually equals to 7. And F2 represents the frequency after that of the modal class, and that is equals to 9. So we call this 9. And the class interval, which is C, is actually the difference between the upper class and the lower class of any class that we can think of. So we have like 6 classes right here: 15 to 20, 21 to 26, down to 45 to 50. So we can just pick any one. So I'm going to pick in the first one, which is 15 to 20. So 20 minus 15, that gives us 5. So that means our class interval is actually equals to 5. So now that we have all our details, it's time for us to substitute them into the formula. So let's take this up a bit. So we have our mode to be equals to, so this is our 32.5 plus, so we open the bracket, we have this to be 18 minus 7 divided by 18 minus 7 plus, we have this to be 18 minus 9 into brackets, then we close the brackets, then we have times 5. So 32.5 plus, so 18 minus 7, that's 11 divided by, we have this to be 11 plus 18 minus 9, that gives us 9 times 5. So I am going to be using my calculator to work on everything we have in this bracket. So we have this to be 32.5 plus, 11 divided by 11 plus 9, that gives us 0.55 times 5. So we have 32.5 plus, so 0.55 times 5, so that gives us 2.75. So we have this to be equals to 34.75. So the modal class of this distribution of R's is actually equals to 34.75. If you learned something new and if you enjoyed this video, I would really appreciate if you can like this video and also subscribe to this YouTube channel and turn on your notifications so that you can get notified when I release new video, which I do at least 2 times a week. Please, if you have any questions, I would really appreciate if you can just comment them in the comment section or drop them in the comment section. And thanks for making it to the end of the video. We would see you in the next one. Bye for now.